All right, guys, let's knock out this chapter, this test 10 review. First three say, or number one of three parts, says find the reference angle for the given angle. Remember, that's talking about the reference angle is how far away your angle is from the nearest x-axis. Must be acute, must be positive. So 199 is 19 degrees away from 180. So the reference angle will be 19 degrees. Number two, or part B, 120 is 60 degrees away from 180. So it is there. And we talked about the trick for part C, 4 pi over 3. Remember, if it's a pi over 3, pi over 6, pi over 4, you can just drop that top number. 4 pi over 3 is really 1 pi over 3 away from being 3 pi over 3, or 180. So you can just drop the top on the radians. Number two, find the exact value. The way we're doing this, we're doing a reference angle first. So the reference angle of 150 is 30. So I'm really thinking about sine 30. And you should know by now that the sine of 30 degrees is, I about messed it up, is 1/2. Now, to figure out if it's positive or negative, look at the quadrant. 150 is in quadrant 2. Remember, sine is the y. Y is positive in quadrant 2. It's 1/2. On part B, cosine 7 pi over 3. I'm dropping that top again. But let's pick up pi over 3. Cosine pi over 3 is also 1/2. You got to think about what quadrant you're in. If you're in 7 pi over 3, you really did this. You really went 1 pi. First of all, 7 over 3 is 2 1/3. So it's really I'm looking at 2 1/3 pi. So it's 1 pi, 2 pi, and 1/3 of another one, which puts me at quadrant 1. Everything's positive in quadrant 1, so it's positive 1/2. Number 3, two parts of this one also. Write the first trig function in terms of the second for the given quadrant, which means I got to write cotangent with just sine, and that's all. So here's what I know about cotangent. I know that cotangent is cosine over sine. So what I basically have to do now is I got to get rid of that cosine and replace it with sines. And here's what I know from another identity. I know that cosine squared plus sine squared is 1. All right, so if I take that sine squared over, that gives me cosine squared is 1 minus sine squared. But I need to replace that cosine. So I'm going to take the square root, which means I'm putting a plus or minus in the front, don't forget, of 1 minus sine squared theta. You can hardly read that. That's terrible, I'm sorry. 1 minus sine squared. I'll try to do better. Sine squared theta, that's a little bit better. Okay, it's 1 minus. I'm struggling right there like crazy. Let's see, square root 1 minus. There we go, sine squared theta. So I'm going to replace that cosine in my numerator with a one square root of 1 minus sine squared. Now, here's the key. It says sine, and it says theta. Theta is in quadrant 2. And I'm replacing my cosine here. So I'm thinking, what is cosine in quadrant 2? Is it negative or positive? Well, it's the x, so it's negative. So on my numerator, I'm going to go with the negative. And I'm going 1 minus sine squared theta. Okay, so there's those. Okay, I'm going to erase that so I have some room here on the B part. B part's the same kind of problem. It says secant in terms of sine. All right, secant. A couple ways you can go here. I'm going to go this way. Secant's really 1 over cosine. And I'm going to do what I just did a second ago. I'm looking back. I didn't erase this, I don't think. I'm going to change my cosine to sine again so that I can write secant in terms of just sine. So I'm going to pull this back down. Look right here. See where I have cosine is plus or minus 1. It's plus or minus the square root of 1 minus sine squared. That's what I'm going to do. I'm going to replace that cosine again with that one, except the difference is this time it's in quadrant 1. And in quadrant 1, everything's positive. So I'm going to replace my cosine with the positive square root of 1 minus sine squared theta. And there it is. I took secant and wrote it in terms of sine instead of cosine like we were used to. Hope that makes a little bit of sense. Number 4, find all the values of trig functions of theta for the given information. First of all, it says secant is 5, which means that's positive, which means this, by the way, which means cosine is reciprocal of that. Cosine is 1/5. So cosine is positive, sine is negative. Think about that. X is positive, y is negative. X is positive, y is negative. That's quadrant 4, by the way. Okay, so there's my sine and cosine. Sorry, my secant and cosine. To find my sine, I'm going to have to go do that thing. I'm going to do the sine squared plus cosine squared is 1. So sine squared, I don't know. Cosine squared, I know cosine is 1/5. So if I square it, I get 1/25, and that equals 1. All right, if I move the 1/25th over, 1 is 25/25, I get 24/25. So sine is going to be the square root of 24 over 5. Square root of 24, by the way, is 4 times 6, so I can write that 216. So there's my sine, 216 over 5, except for one thing, and that is the sine is negative right there, so I'm going to make that negative. Cosecant is going to be the reciprocal of sine. So if I flip that, I get this, I get negative 5 over 216. Don't forget our little shortcut. The square root goes to the top. On the bottom, it comes out. If you pull 6 out of there, it gives you 6 times 2, which is 12. So there's my cosecant. There's my sine. There's my cosine. Now, when I get the tangent, don't forget tangent is just sine over cosine. So if I put sine, which is this, over cosine, which is this, obviously your 5's cancel. You just get negative 216. Cotangent is reciprocal of tangent. I would have this. All right. The radical goes to the numerator. It comes out on the bottom, which gives me negative 12 because there's already a 2 down there. So if you pull the 6 out, you got to do 6 times the 2. All right. Quite a bit of stuff on that one. I like that problem, though. Okay, number 6. Find the area of the triangle with these two sides, and it includes an angle included of 10 degrees. So with that one, we're going area of the triangle is 1/2 the two sides and the included angle, and it's sine of the included angle. Okay, so you can just take that right there and punch it straight into your calculator, which I'm about to do. If I get my open, let's see. So I'm going 0.5 times 10 times 12 times sine of 10 degrees. Make sure you're in degree mode, by the way. If you're not, you'll get the wrong answer. Hit enter, and I'm getting 10.42 for the area of that triangle. Okay, not a big deal there, but you do need to know the formula. It's 1/2 the two sides times sine of the angle. Say the property. All that happened here is the x plus 2 is first. It was first, and b was second. Over here, the x plus 2. Oh, they changed the x plus 2 to 2 plus x. That is called the commutative property. When all that they do is change the order, is commutative. You know what distributive looks like. You know what associative looks like. That's commutative. All right, simplify. Now we're back to review. My advice on this one right here especially is to do everything inside first. What I see inside is I see this, there's the next exponent on the top, so I'm going to go ahead and take care of that. When you do that, you're going to get this and 12. On my denominator, I have r squared s squared, and I still got that square outside. You can still do some things inside. I'm going to take this r down to the bottom, make that r to the 5th. The s's on the top, subtract your exponents. I have that. If you square, when you raise a power to a power, you multiply your exponents, you get s to the 20th, r to the 10th. Donezo. There it is. Inside out, the best way to go. Number 8, we've had this quite a bit lately. Find g of f of x. I'm going to put g into function f. It's going to look like, let's see. Oh, no, backwards. Sorry about that. I didn't read that. G of f of x. I'm putting f of x into g. So it's going to look like, let's see, g of f would be 1 minus this square root, as if you're squaring the square root. Okay, so that'd be 1 minus, the square root's gone now, so I just get 1 plus x, which is just going to be x. So those are inverses of each other, but it also says domain. Remember domain, you start with the second one right here. The second one for domain of this, it's got to be positive in there, so I'm gonna do this. Just move the x over. So here's what's got to be true. X, you have to plug in something there less than 1. And then compare that to your final answer, which is just x, which would be all reals. And that's what they have in common. Well, what they have in common is the x is less than 1 part. Because x, all reals includes everything. X is less than 1 includes the less than 1 stuff. So your domain would be all x such that x is less than 1. There's your domain. There's your answer to g of f of x. And again, the way you do domain, one more time, you take the one that's inside, this one. You compare that domain to the domain of your final answer, and that's how you get your domain for the composition. Number 9, is it 1-to-1? It's only 1-to-1 if it passes the horizontal line test. And if you look at your, you can punch it in your calculator if you want. It's one you should know though. It's gonna go up that way, down that way. That's what it's gonna look like. Hello, it went away. There we go. Look Looks just like that. Does it pass the horizontal line test? Yes, it does. Therefore, yes, it is 1-to-1. All there is to it. Number 10, determine it's even, odd, or neither. B's a little bit smart here. All the exponents are odd. It is not going to be even. You don't even need a test for even. 2 ways you can test for odd. One way is you can plug in a negative y and a negative x. That's the algebraic way to test for odd. And if I do that, let's see what I get here. I get a negative y over here. That stays negative. This one changes to positive. So here's the deal. Is that right there exactly like that, or is it the exact opposite of that? Or is it neither one of those? And this time it is the exact opposite, so that means, yes, it is odd. Okay, that's one way. One way is to plug in a negative x and a negative y. By the way, if you're testing even, if tomorrow you're testing even, you just plug in a negative x only. The other thing you could do is you could plug that in your calculator and graph it. Okay, odd means it's symmetric with the origin. You should see something where if you turn your calculator upside down, it looks exactly the same right side up. Even is symmetric with the y-axis. Okay, so you can also take this, punch it in your calculator, look at the graph, and see what happens that way. All right, hope that makes some sense to you. Some good stuff on that test, so watch it as much as you need to. You can skip around this video as much as you need. Come see me tomorrow before the test if you have any questions. Look forward to seeing you.